Yeah, that's a great example. I mean, it's not really that the DNA changed, so DNA stayed intact. What changed is the expression of the DNA. The DNA is really the blueprint in your body on how to make proteins, hormones, how to fix your body if you get injured. So what changed is the expression of those genes in the DNA, and that has to do with pretty much all of the physiology and the changes in space, like radiation, zero gravity, and why not. So just recently, there was also a big publication in Nature, which I'm fortunate enough to be one of the co-authors on that one, regarding the Inspiration 4 mission, which was, significantly shorter in duration, just 3 days, but the depth of omics and genomics testing that we did in that mission is extremely significant. So I guess short answer to your question is that there are significant changes in the expression of genes in spaceflight, but you see them pretty much go back to normal after, weeks or months after they come back to Earth. So the human body is pretty resilient to these changes. Now the caveat is that the twin study was a sample of two, right? Just two people in space, Kornienko and Kelly, and then Kelly's twin brother Ned. So it's very difficult to extrapolate or make significant conclusions when you have a very small sample size. Um, Same thing with the Inspiration 4 mission, only four subjects, very short mission. But I think the value of these two missions is to show us that the field is already there, the technology is already there to help us look very, very deeply in the human body, all the way down to the expression of the genes, and helps us understand the physiology, which is usually what you traditionally see, with blood pressure and why not. So this new piece of the puzzle helps us understand why we're seeing those changes at the physiology and really the way that the astronauts feel and experience spaceflight.